everybody. Today we'll be going through binary tree level order traversal. So given the root of a binary tree, return the level order traversal of its nodes value from left to right, level by level. So here we can see we have three levels, for example, and we want to output a list of lists which contains all the nodes in its respective level. So for example, when the root is given by 3, 9, 20, and now 15 and 7, then we want to output 3 in the first element in the list of lists, and for the second element we need to output the second level, which is 9, 20, and for the third one we need to output 15 and 7. And for the example 2, if the root is 1, we just need to output 1 in the list of lists. And for example 3, if there's nothing, then we output an empty list. So we have the binary tree from example 1. And what we can do here is, normally for this kind of questions, we either use a BFS, breadth first search, or a DFS, depth first search, in order to traverse a tree. So since this question wants us to traverse it layer by layer and input the values into a list of lists, we will use the BFS algorithm. And the data structure for this kind of algorithm is to actually use a queue. Whereas for the BFS, we can either do recursion or we can use a stack. Okay, so let's use the queue to solve this question. Let's say we have a queue here. What we can do first is to push the first node, which is the root node, number 3, into the queue. Once we have the node in the queue, we check whether the queue is empty. If it's not empty, we can actually do some operations on it. So instead of popping this node from the queue first, we use the method pick. So pick will allow us to check what is at the front of the queue without actually popping this element out of the queue. So we use pick, we check whether the left and the right is null. If it's not null, we want to push the elements into the queue. So for example 3, it has a left child, is not null, so we push the left child into the queue. And the right child is 20, it is not null, so we push 20 into the queue. So only when these two elements is already in the queue, then what we want to do is to pop this front element and we can put it into a temporary list. Okay, so we have this final answer list. So this final answer list will actually contain all our temporary list elements. So we can put this here. And now we can go back to checking whether the queue is empty. If it's not empty, we can operate on this front element. So now let's check for 9. For 9, we can see that it doesn't have a left child. It also doesn't have a right child. So we can just pop this element out. And we push it to a temporary list. And we do for same for 20. 20, actually we see left child. It has a left child, so we push 15, and it has a right child, so we push 7. and then we pop, and then we put it into the temporary list. Okay, so now we are done. We can add this to the answer. This is the answer list. Okay, now we continue checking whether the queue is empty. It is not empty, so we check 15. Does it have a left child and right child? No, it doesn't. Same for 7. It doesn't have a left child and right child. So 15 first, it will go into a temporary list. And same for 7. Now that we have these 2 elements in the list, we can add it into our final answer as well. So this will be the final answer. 3, and we have 9, 20 in another list, and we have 15 and 17 in its own list. Okay, so let's go to the code. So first, we will have a list of lists, and then we'll use a queue, and this queue will store the 3 nodes. And then we check if the root is null. We just return the answer. Now we will push the root node first. So we use offer, and then we check whether this queue is empty. So if it's not empty, we can do some operations on it. So first we get the number of nodes, and this is actually just the queue size, and we will have a temporary list. So this is where we push our temporary list, and then we add it to the final answer list. So for in I equals to 0, I less than number of nodes. Here we will use the peek functionality. So we check at the front of the queue whether it has a left child. So if left is not null, then what we want to do here is we will push the left child into the queue, and we also do the same for the right child. If it's not null, we will push the right child into the queue. Once this is done, then we can use the temp.add, and then we pull the front of the queue. So we just need the value. And after this for loop, we just add the temporary list into the final answer list, and we return the answer. So this is it. Let's try to run it. Yep, and let's submit. So it's successful, and this is how you solve this question.